Hello and welcome to Philobytes. In this video, we are going to talk about the formal nature of syllogistic arguments, and we are also going to learn how to draw Venn diagrams for testing the syllogisms. Now, what do we mean by formal nature? The constituent propositions of a syllogism are all contingent, that is, no one of the propositions is necessarily true or necessarily false. Under this assumption, the validity or invalidity of any syllogism depends entirely on its form. Validity and invalidity are completely independent of the specific content of the argument or its subject matter. So what we are trying to understand over here is that the validity or invalidity of the syllogism will depend on the form, not on the content. For the constituent propositions of the syllogism, they're contingent. That is, they are not necessarily true or necessarily false. They are all probable. So if every proposition is a probable proposition, how are we going to determine their validity or invalidity? That will be determined by their form alone. Now let's understand what is this form. We have already discussed about the form of the syllogisms in the previous video. So for example, any syllogism of the form AAA1 is valid. That is, the first two premises are universal affirmative propositions and the conclusion is also universal affirmative proposition, and the figure is 1. In this case, the form will be AAA1, and this form is always valid regardless of its subject matter. And remember that every valid form has a name, and the name of AAA1 is Barbara. No matter what what classes are substituted for the letters S, P, and M, the resulting argument in Barbara will always be valid. So a valid syllogism is valid due to what? Due to its form alone. So that is why we say that syllogistic arguments are formal in nature. So if any syllogism is valid in virtue of its form alone, any other syllogism having that same form will also be valid. And if a syllogism is invalid, then any other syllogism having that same invalid form will also be invalid. So this is what we mean by the formal nature of a syllogism. Now consider the following argument. All liberals are proponents of national health insurance. Some members of the administration are proponents of national health insurance. Therefore, some members of the administration are liberals. The form of this argument is AII2, and this is invalid. Now, just by looking at this syllogism, you may not be able to understand whether it is valid or invalid. So what you're going to do is you're going to replace the major, minor, and middle terms with some other class and form another set of syllogism. So based on this form AII2, and by replacing major, minor, and middle term with some other content, we can write all rabbits are very fast runners. Some horses are very fast runners. Therefore, some horses are rabbits. Now, just by looking at this syllogism, you can immediately say that it is invalid. You don't have to test it in any way. So this proves that the argument above, the previous argument about all liberals, that is also invalid. This is a proof that if the form is invalid, then any argument in that form will be invalid. So we can say that the previous argument is also false because it has the same invalid form analogous to this one. And this process, the way of comparing, is known as arguing by logical analogy. So underlying the method of logical analogy is the fact that the validity or invalidity of such arguments as categorical syllogisms is a purely formal matter. Any fallacious argument can be proved to be invalid by finding a second argument that has exactly the same form and is also known to be invalid by the fact that its premises are known to be true while the conclusion is known to be false. So I hope you have understood why the categorical syllogisms are known by their formal nature. What is the meaning of formal nature? Now, this formal nature, this method by logical analogy has some limitations. Let's see what the limitations are. Sometimes a logical analogy is difficult to think up on the spur of the moment. There are far too many invalid forms of syllogistic arguments for us to prepare and remember refuting analogies of each of them in advance. So suppose you cannot identify a syllogism as valid or invalid, and immediately it may not be possible for you to think up another analogous argument of the same form in order to verify the truth of the one that you're stuck on. Second problem is, even if you're not able to think of another analogous syllogism, it is highly possible that there is an invalidating analogy corresponding to the one that you're trying to evaluate. In that case, it will be very troublesome for you to understand whether a given syllogism is valid or not. So it is because of these reasons that the logical analogy method is not 100% dependable, or it is not so convenient. For that reason, what we are going to do now is we are going to learn the Venn diagram method, with the help of which we can identify the syllogism to be valid or invalid. So now we come to Venn diagrams. In order to test a categorical syllogism using Venn diagrams, one must first represent both of its premises in one diagram. You have to remember here that the two premises contain three terms: the middle term, major term, and the minor term. Corresponding to that, the circles that you're going to draw overlapping one another are also going to be 3 in number. So you have to draw 3 overlapping circles for the two premises of the standard form syllogism containing 3 different terms: the minor term, major term, and the middle term, which we are going to abbreviate as S, P, and M respectively. So you can see that there are 3 circles overlapping one another. The red circle is named as S, the blue as P, and the green as M, corresponding to the minor term, major term, and middle term. We have learned that P is always the major term and S is the minor term, while M is the middle term. So in this way, first draw the 3 circles. Now, what you're going to do is you're going to draw the 3 circles SPM exactly in this order, and then you're going to write SPM in all the 7 sections inside the circles. The 8th section is outside of the 3 circles, and we'll talk about that later. Now we will put the bars whenever needed. So here you see the first arrow is SP bar M bar. Why? Because it is that area of S, the red circle, which has only the class S, but P and M are absent. Hence, we write S P bar M bar. The second arrow shows the area of S P M bar, because that is the area where you will find little bit of S and also P, but not any trace of M. So M, you put a bar on M. So that area, that is the arrow 2, will be SPM bar. Okay, so arrow 3 is the area where only P is present, but S is absent and M is also absent. So we will write S bar P M bar. Similarly, in arrow 4, you will see P and M. Both of these classes are present, but S is not present. So it is going to be S bar PM. The fifth area, that is the fifth arrow, is the area where only M is present. So S bar P bar M. Now arrow 6 is the intersection of S and M. So you will find S over there and also M over there, but P is absent. So you're going to write S P bar M. And finally, the seventh arrow is this common section where you will find all the three classes S, P and M. So I hope you can see that. Okay, and outside the three circles is the area where S, P, M are all absent. So S bar, P bar and M bar. So you're going to write this is the absence of all the classes. Now, before actually trying to test the syllogism with the help of Venn diagrams, we have to remember this. We did this in earlier videos. That is the symbolic representation of the categorical propositions. A proposition, all S is P, is symbolically represented as SP bar is equal to 0. E is no SSP, it is symbolized as SP is equal to 0. I proposition, some SSP is symbolized as SP not equal to 0. And O proposition, some S is not P, is symbolized as SP bar is not equal to 0. You also need to remember how to represent the propositions in Venn diagrams based on the symbolisms. So when the symbolism is SP bar equal to 0, that is the A proposition, you're going to shade this area of S, as you can see in the first figure. When the symbolism is SP is equal to 0, that is, it is representing the E proposition, no SSP, you're going to shade the common area between S and P. When you get the particular proposition, SP is not equal to 0, you're going to write an X in the common area of S circle and P circle. And in the O proposition, some S is not P, symbolized as SP bar not equal to 0, you're going to just put one X in the area of the S circle. I hope you have to you remember this, because otherwise it will be impossible for you to test the validity of syllogisms with the help of Venn diagrams. So now let us understand how to test syllogisms with the help of Venn diagrams with an example. Always remember, the three circles do not mean two premises and one conclusion. They mean three terms of the syllogism. The three overlapping circles diagram the three terms which belong to the two propositions, which are the two premises. Now, if after marking the Venn diagram, we find that the conclusion is already marked in the figure, then the syllogism will be valid. Otherwise, it will be invalid. It would then mean that the conclusion is implied or contained in the premises themselves, which means it is valid. What I'm trying to say is the three circles represent the three terms used in the two premises. Now, after shading or putting X or whatever, marking the three terms in the Venn diagram, you will find either the conclusion is already marked while marking the premises, in which case the syllogism will be valid, or you will find an area in the circles is left out. That is, the conclusion is not marked while marking the premises. In that case, you can say that the conclusion is not contained in the premises and therefore it is going to be invalid. Okay, so let's consider this syllogism. All artists are egotists. Some artists are paupers. Therefore, some paupers are egotists. So, the conclusion will contain the major term and the minor term. The major term will be egotists. That is the predicate term of the conclusion. S will be the minor term, which will be paupers. So if paupers is S and egotist is P, then which is the term which is left out in the conclusion? It is M, which is the middle term, or artists in this case. Now let's see how to do the Venn diagram. Now the given argument can be symbolized as follows. All M is P, some M is S, therefore some S is P. Now all M is P is symbolized as MP bar is equal to 0. The second premise, the particular one, will be MS not equal to 0 and the conclusion will be SP not equal to 0. Now after drawing these three overlapping circles, and marking them with SP and the relevant bars, we are now going to shade out the first premise, which is also universal proposition. So the first premise, since it says MP bar, we are going to look for MP bar in the areas inside the circles. So which are the areas which contain MP bar? MP bar, we can find it appears in two regions. Those two regions I have marked with yellow dots. One is SP bar M, the other one is S bar P bar M. Now ignore the S's at this point of time. Just find out where you are finding MP bar. That's it. Now after locating MP bar, because it is a universal proposition, you are going to shade these two areas. However, I have not shaded because of technical constraints. It is not possible for me to shade out my presentation online. That is why I've just put two yellow dots. But you're going to shade these areas. Okay. Now, after shading the universal proposition, we will mark the second premise, that is a particular proposition, with an X. The second proposition was MS not equal to 0. So that means we are supposed to locate MS in the circles. So one MS is very clear and distinct. It is just in the middle of the three circles. It is the area of SPM. There is another area where we find M and S. That is the area which we have already shaded while shading the first premise. It is SP bar M. There also we find MS. Okay, so we are going to put an X in the common line between these two areas. So we are going to write X over there. You can see the red colored X. I've written it there. So now let us consider the conclusion, which is SP, and let's see that after shading and marking the universal and the particular proposition, has the conclusion been automatically marked or not? If it has been automatically marked, then this will be a valid syllogism. Otherwise, it will be invalid. So, since the conclusion is also a particular one, so it is enough that we find at least one in order to validate the syllogism. And you will see the conclusion was SP not equal to 0. And where do we find SP? SP, you can see, is again found in the middle. That is where you have put the X. And also you will find SP just above it, where I've put a blue star. Okay, that area is SPM bar. You can say that area has not been marked or shaded in the premises, but it doesn't matter because the conclusion is a particular one, and at least one is enough to justify, and at least one member is there. This has been proved by the fact that SP has been marked in the areas where we have written X. So this is a valid syllogism. And I forgot to tell you that this is AII3. This is the form of the syllogism, and always remember that AII3 is a valid syllogistic form. Now let us see how an invalid syllogism will be shown in a Venn diagram. All dogs are mammals. All cats are mammals. Therefore, all cats are dogs. Obviously, this is invalid. We can readily understand that. Now, it will be symbolized as all P is M, which is PM bar. All S is M, that is SM bar. And the conclusion, all S is P, that is SP bar. Okay, so let's see how it will look like in a Venn diagram. So let's mark the Venn diagram now. The premise 1 was PM bar, and here you will find it marked in green. So one area is SPM bar, the other area is S bar PM bar. So because this is again a universal proposition, you're supposed to shade these areas, not put dots like I have done. The next premise is another universal proposition, and again you're going to shade it, and this time it is SM bar. SM bar is found, I've put two black stars. In the one area is SP bar M bar, and the other area is SP M bar. Now the conclusion was SP bar. You can see the area SP bar M where I have put a red cross. That area has not been shaded while shading the premises. So that is why the conclusion has been left out. It has not been included while marking the premises. So that is why this is an invalid argument. And because the conclusion is also a universal proposition, that is why we cannot just because we have marked a portion of SP bar will not justify the conclusion. It is a universal proposition, so all the areas which has SP bar must have been marked in the premises. That is mandatory. So that is why we can say that this argument has been proven to be invalid. Now this was AAA2. This was the form of this argument, and you can always remember that AAA2 is an invalid syllogistic form. Now where do I place the X in Venn diagrams? When one of the premises of the syllogism calls for an X to be placed on a line, in such a Venn diagram, we may ask which line and why. The answer is that the X is always placed on the line of the circle designating the class not mentioned in that premise. Say for example, the premise is sum S is M. So you will symbolize it as Sm not equal to 0. Now where do you find Sm? Sm you will see appears in two places. One is Spm, the other area is Sp bar M. So where will you write the X? You will write X in the common line which is including both these areas. So exactly the blue common line which you can see in this figure where I have written X. So then X is to be written along the border of the two relevant circles. This is very important. You cannot write X just in SPM or SP bar M. You have to write X in the common line. Okay, so now let's try to solve this problem. Write out each of the following syllogistic forms using S and P as the subject and predicate terms of the conclusion and M as the middle term. The form which has been given to you is EIO2, which means this is figure 2, which also means that the middle term M is going to appear in the predicate position of both the premises. Now we will first write the conclusion. We know the subject and the predicate terms of the conclusion, that is S and P. We also know that the conclusion is an O proposition. So how are we going to write it? We will write sum S is not P, the particular negative proposition, which is the conclusion. Now, the predicate term of the conclusion, that is P, is also the major term. And the major term will appear in the major premise. So P is going to appear in the major premise, that is the first premise. And what is the other thing we have to remember as far as the major premise is concerned? We have to remember that M should appear in the predicate place. And we also have to keep in mind that the first premise is a universal negative proposition. So what we can frame it as is no P is M. That is Pm is equal to 0. Similarly, we have to think about the second premise. The second premise is I, that is sum S is P, something like that. That is the form it should take. Here S is the subject position, subject term of the conclusion. Therefore, the subject term of the conclusion is also the minor term and it should appear in the minor premise, that is in the second premise. So in the second premise, we are going to write S. And we are also going to write M, but in the predicate position. Why? Because remember, this is figure 2 where the middle term appears in the predicate position in both the premises. Next, we have to remember that the minor premise or the second premise is a particular affirmative proposition. So how can we frame it? It is going to be sum S is M or Sm not equal to 0. So now we have got the entire syllogism in this pattern. No P is M, sum S is M, therefore sum S is not P. Now the first premise, which is the universal premise, Pm is equal to 0, that should be shaded first because it is a universal premise. So look into the figure. Where do you find Pm? You will find Pm in two areas where I have put two green dots. Okay, so you're going to shade these two areas completely, because this is a universal proposition. The second premise is a particular one. Here you're supposed to locate SM. You will see SM appears in two areas. One you have already marked, which is SPM, while shading the universal proposition. Another one is remaining, which is SP bar M. Now because SM is common to both the areas, you're going to write X in the blue bordering line, which is in between SPM and SP bar M. Now you've finished marking and shading the premises. Now let's focus on the conclusion. The conclusion is also a particular one, and what we are going to look for is SP bar. Has SP bar been marked or not? Yes, we have already marked SP bar. Okay, we have already marked SP bar because you can see uh, the cross which is lying in the common line between SPM and SP bar M. So which means there is at least one member of SP bar also in SP bar M, which has already been marked in the premises. And because the conclusion is not claiming a universal truth, therefore we can say that this is a valid syllogistic form. Next question. Put each of the following syllogisms into standard form, name its mood and figure, and test its validity using a Venn diagram. So this is a very complete question in the sense that you're going to apply all that you have learned as of now in order to solve these questions, and it is going to be a good practice for you. So no musicians are astronauts. All musicians are baseball fans. Consequently, no astronauts are baseball fans. So immediately the first task is to identify the conclusion. Because of the word consequently, which is a conclusion indicator, we can say that no astronauts are baseball fans. This is a conclusion, and you must write the conclusion at the very beginning. Otherwise, you might get confused. Now, if no astronauts are baseball fans is the conclusion, then baseball fans is the predicate term of the conclusion, which means baseball fans is the major term, is also the major term, and the major term will appear in the major premise. So which is the major premise? The major premise is all musicians are baseball fans. You can easily locate the major premise. Now, astronauts is the minor term of the conclusion. So, the minor premise will be no musicians are astronauts. So, now you have the entire syllogism in front of you in standard form, which is all musicians are baseball fans, no musicians are astronauts, therefore no astronauts are baseball fans. Now it will be very easy for you to write them in write their mood and figure. You will see that here musicians is the middle term. So if musician is the middle term and it is appearing in the subject position of both the premises, then you can say that it is figure 3. The first premise is an A proposition, the second one is an E proposition, and the conclusion is also an E proposition. So the form of the syllogism will be AEE3. Okay, so we have identified the mood, the figure, and basically we have also symbolized them. All M is P will be MP bar equal to 0. No M is S will be MS equal to 0. And no S is P will be SP equal to 0. We need this symbolization because we are now going to test the validity of this syllogism with the help of Venn diagram. Okay, so now in this syllogism, all the three propositions are universal propositions. Okay, so the first premise is MP bar. Where do you find MP bar? In two regions. One is S bar P bar M. The other one is S P bar M. And I have tried to shade these two areas. I hope you can understand that. The next premise is MS is equal to 0, and MS is also in two places. One is SPM, the other one is SP bar M. So again you are going to shade these two areas. Now the conclusion is SP is equal to 0. Has SP been shaded by the premises? Let's see. No. We can find SPM bar, the region where I have put a question mark. That area has not been shaded when we were shading the premises, which shows that this syllogism is invalid. That is, this argument was an invalid one. Okay, so I hope that you have understood whatever we have discussed in this video, why syllogistic arguments are supposed to have a formal nature, and how the syllogistic arguments are tested with the help of Venn diagrams. If you get stuck in any questions that are given on the pages 229 to 230, message me. I will solve it for you and post it immediately. So I'll be too happy to help you. So bye bye for now. See you soon. So in the next video, we shall cover syllogistic rules and syllogistic fallacies. That will be logic part 11. So I hope you will not miss it. Thank you for joining. Bye-bye.